Hari Om. Hello everyone, I am Shrees. Welcome back to my channel. In this video, we are going through some important questions of permutations and combinations. Very important chapter because see, if you understand the concept of permutations and combinations, you would be able to understand the concept of probability. That is why this chapter is very important. So first of all, here let us go through problems of factorials. See, we know that factorial n factorial is equal to n into n minus 1 into n minus 2 into n minus 3 etc. into 1. See, it is the n factorial. Okay, n factorial is equal to n into, okay, multiplied with n minus 1 into n minus 2, n minus 3 into etc. up to 1. Okay, so here first question is compute 11 factorial minus 10 factorial divided by 9 factorial. So here, see, first of all, let us write 11 factorial. See, 11 factorial is nothing but 11 into 10 into 9 into 8 into etc. into 1. So here up to 10, see here, this can be written as 10 factorial, right? So 11 factorial can be written as 11 factorial can be written as 11 into 10 factorial minus, write 10 factorial as it is, divided by 9 factorial. See, 9 factorial is nothing but 9 into 8 into 7 into etc. into 1. But here no need to write because it will be cancelled. Okay. So 9 factorial. See here in numerator 10 factorial is the common, right? So let us take it out. 10 factorial into 11 minus 1 divided by 9 factorial. Okay, that is nothing but 10 factorial into 10 divided by 9 factorial. That is equal to, here see, 10 factorial can be written as 10 into 9 factorial, right? Into 10 divided by 9 factorial. So that this 9 factorial will be cancelled. So here 9 factorial is cancelled. So remaining 10 into 10, that is 100. Therefore, its value is 100. Next, second one, we have to find the LCM of 6 factorial into 7 factorial into 8 factorial. See, 6 factorial can be written as 6 factorial. Okay, write as it is. Next, 7 factorial, it can be written as 7 into 6 factorial. So here, see, among these numbers, 6 factorial is the smallest, right? So therefore, write 6 factorial as it is, okay? So next is 8 factorial, that can be written as 8 into 7 into 6 factorial, okay? So here we have to find the LCM, that is least common multiple of these numbers, that is nothing but 8 into 7 into 6 factorial. So LCM of 6 factorial, 7 factorial, 8 factorial, that is equal to 8 factorial. Okay. Therefore, LCM of 6 factorial, 7 factorial, 8 factorial, that is equal to 8 factorial. That is largest among these numbers. Okay. That is the LCM. Next question. Find x in each of the following. First one, 1 by 4 factorial plus 1 by 5 factorial is equal to x by 6 factorial. So from this we have to find the value of x. 1 by 4 factorial plus 1 by 5 factorial is equal to x by 6 factorial. Okay, see here, first of all let us consider LHS and find the LCM of LHS. That is, see here, what is the LCM of 4 factorial and 5 factorial? That is nothing but 5 factorial. That is largest number, that is 5 factorial, right? So here 5 factorial, see, we can write it as 1 by 4 factorial plus 1 by 5 factorial is nothing but 5 into 4 factorial, right? That is equal to x by 6 factorial. So here we have to multiply 5 here for first term, right? So 5 divided, because 5 factorial is the LCM. So 5 divided, 4 factorial is here. So only we have to multiply 5. So 5 divided by 5 factorial plus here 1 by 5 factorial is equal to x divided by 6 factorial. Okay, that implies here 5 plus 1, 6 divided by 5 factorial is equal to x divided by 6 factorial. Okay, here 6 divided by 5 factorial, x divided by 6 factorial can be written as 5 factorial, sorry 6 into 5 factorial, right? 6 into 5 factorial. So here 5 factorial cancelled. That implies 6 divided by 1, that is equal to x divided by 6. Okay, that implies take 6 here, so it will be x is equal to 36. Next, second one. Here let us take the LCM of right RHS. Okay, x divided by 10 factorial is equal to, here 1 by 8 factorial plus 1 by 9 factorial can be written as 9 into 8 factorial, right? See here 9 factorial is the LCM, so we have to multiply 9 here, okay, because here only 8 factorial. So 9 plus 1 divided by 9 factorial, right? So x divided by 10 factorial is equal to 10 by 9 factorial. That implies x divided by 10 factorial is equal to 10 divided by 9 factorial. And 10 factorial can be written as 10 into 9 factorial, that is equal to 10 divided by 9 factorial. So here 10 factorial is cancelled and take 10 here right side, so it will be x is equal to 10 into 10, that is 100. So here x value is 100. See the next question. Convert the following products into factorials. Very important question. First one, 5 into 6 into 7 into 8 into 9 into 10. See, here we are not able to write the numbers into factorial, right? See, we cannot write 10 factorial. Why? Because some numbers are missed, right? We know that 10 factorial is nothing but 10 into 9 into 8 into 7 into etc. 2 into 1, right? That is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. So let us multiply missed numbers. So here let us multiply 1 into 2 into 3 into 4, okay, into 5 into 6 into 7 into 8 into 9 into 10. Now let us divide the number which is multiplied here in numerator, okay, that is 1 into 2 into 3 into 4. Now see, numerator we can write it as 10 factorial. All the numbers are here, right? That is 10 factorial divided by, it is nothing but 4 factorial. 4 factorial is 1 into 2 into 3 into 4. That is 4 factorial. Okay, now let us go through second one. See, second one. Here, see the second one is 3 into 6 into 9 into 12 into 15 into 18. See, we know that all these numbers are multiples of 3, right? So we can write it as 3 into 1, okay, into 3 into 2 into 3 into 3, okay, 3 into 4, 3 into 5, 3 into 6, okay. Now here, see how many numbers are here? 6 numbers, right? So let us all these 3 outside. That means 3 into 3 into 3 into 3 into 6 times, right? That is 3 raised to 6. So it is equal to 3 raised to 6 into, and remaining numbers 1 into 2 into 3 into 4 into 5 into 6. That is equal to 3 raised to 6 into, it is nothing but 6 factorial. Okay, so it is nothing but 3 raised to 6 into 6 factorial. Okay, now let us go through third one. Third one, see, third one is n plus 1 into n plus 2 into n plus 1 into n plus 2 into n plus 3 etc. 2n. Okay. See, here also we cannot write it in directly factorial, because see, some numbers are missed, right? That is till n. Okay. 1 into 2 into 3 into etc. up to n numbers are not here. Okay. If it is here, we can write it is 2n factorial. So let us multiply 1 into 2 into 3 into etc. up to into n. Okay. We have multiplied this one into n plus 1 into n plus 2 into etc. into 2n. Okay. So next let us divide the number which is multiplied in numerator. Okay. That is 1 into 2 into 3 into etc. up to into n. Now numerator can be written as 2n factorial, right? All the numbers are right here. 1 into 2 into 3 into etc. into n plus 1 into n plus 2 etc. 2n. Therefore, it is nothing but 2n factorial. Divided by, see, 1 into 2 into 3 into etc. into n, that is nothing but n factorial. And remember, here you cannot cancel n factorial. Okay, it is different. 2n factorial is 2n factorial itself, not 2 into n factorial. Okay, so here it is n factorial. So you cannot cancel. Next is 1 into 3 into 5 into 7 into 9 into etc. into 2n minus 1. See, here only odd numbers are here, right? So no even numbers. Middle numbers are missed. So we cannot write directly in factorial. So here also we have to multiply some numbers, that is even numbers. Okay. Let us multiply even numbers, that is 2 into 4 into 6 into 8 into etc. into 10. Okay, not 10. See, up to where? Here 2n minus 1. Okay, so previous number is 2n minus 2. Okay, even number 2n minus 2. It is 2n minus 1, that is odd number. So previous even number is 2n minus 2. So 2n minus 2. So up to here we have multiplied. Okay, into, next is 1 into 3 into 5 into 7 into 9 into etc. into 2n minus 1. Okay, so next here also let us divide the number which is multiplied in numerator, that is 2 into 4 into 6 into 8 into etc. into 2n minus 2. Now see the numerator, see it can be written as, see all the numbers are, rewrite this one. That is 1 into 2 into, see 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 etc. into 2n minus 2 into 2n minus 1. Okay, into 2n minus 2 into 2n minus 1. So here, and denominator is 2 into 4 into 6 into 8 into etc. into 2n minus 2. That is, see, numerator can be written as, see the numbers up to 2n minus 1, right? So from starting from 1 into 2 into 3 into 4 into etc. up to 2n minus 1. So that is nothing but 2n minus 1 factorial. Divided by, see, here we cannot write directly in factorial, right? Because, see, odd numbers are missed. So we can write it as, see, all numbers, see, in all numbers, 2 is common, right? So let us take 2. Okay, see, how many numbers are here? Up to 2n minus 2. See, if you take 2 outside, it will be, see, n numbers are here, right? That is 2 raised to n into 1 into 2 into 3 into etc. into n minus 1. Okay, so n minus 1. Therefore, how many n's are here? 2 raised to n minus 1. Okay, 2 raised to n minus 1 numbers are here. Therefore, 2 raised to n minus 1. To n minus 1, 2's are here. So, we have taken it out. Okay, that is 2 raised to n minus 1 into 1 into 2 into 3 into etc. into n minus 1. That is 2n minus 1 whole factorial divided by 2 raised to n minus 1. It is nothing but n minus 1 factorial. Look at the next question. Prove that n factorial into n plus 2 is equal to n factorial plus n plus 1 factorial. So here let us consider RHS, that is n factorial plus n plus 1 factorial. That is equal to n factorial plus, see, n plus 1 factorial can be written as n plus 1 into n factorial. That is like, see, 10 factorial can be written as 10 into 9 factorial, right? That is 10 into 10 minus 1. So here also n plus 1 factorial can be written as n plus 1 into n plus 1 minus 1. That is n. Okay, so n factorial. So that is equal to, see, both terms n factorial is common. So let us take it out. N factorial into 1 plus, here remaining n plus 1. That is equal to n factorial into n plus 1 plus 1, n plus 2. Okay, see, it is nothing but LHS. Hence it is proved. Next question. A person wants to buy one fountain pen, one ball pen and a pencil, okay, one pencil from a stationery shop. If there are 10 fountain pens varieties and 10 ball pens varieties and 5 pencil varieties, in how many ways can he select these articles? See, here a person has to select a fountain pen out of 10 fountain pens, okay, and he has to select a ball pen out of 12 ball pens, okay, and he has to select a pencil out of 5 pencils. So here the number of ways, okay, number of ways to select a fountain pen out of 10 fountain pen is, that is 10C1. Combination 10C1, that means 10 ways. He can select 10 ways, right? Because there are 10 fountain pens. So he will select a fountain pen out of 10 fountain pens. The number of ways is 10, right? So number of ways selecting a fountain pen is 10C1, or you can write directly 10, okay, 10 itself. 10C1 is 10 itself, okay. And why it is combination? See, here he has to select pen, pencil and a fountain pen. See, there is no order, okay. Here order does not matter, that is combination. If order matters, then it will be a permutation. So here you can write directly the number of ways of selecting a fountain pen is 10. See, we can write, that is 10 times we will select the fountain pen, right? And next is the number of selecting, number of ways of selecting a ball pen is, see, out of 12 ball pens, we have to select a ball pen. That is, number of ways of selecting a ball pen out of 12 ball pens is 12C1 or 12, okay. That is 12C1. That is equal to 12. Next, pencils. Number of ways of selecting a pencil is 5C1, that is equal to 5, okay, 5 itself. Therefore, the number of ways of selecting these 3 articles is nothing but articles is equal to 10 into 12 into 5. That is 12 into 5, 60. 10 into 60, that is 600 ways. So in 600 ways, he can select these articles. Next question. There are 4 parcels and 5 post offices. In how many different ways can the parcel be sent by registered post? See, in this question, there are total 5 post offices and 4 parcels. Okay, so one parcel can be posted in 5 ways, right? Because there are 5 post offices. So one parcel can be posted in 5 ways, that is in either of the 1 post offices, right? That is, a parcel can be posted in 5 ways since there are 5 post offices. That is in either of 1 post offices. Therefore, the total number of ways the parcel be sent by registered post is 5 into 5 into 5 into 5, because there are 4 parcels, right? So one parcel can be posted in 5 ways, okay, and there are 4 parcels. Therefore, the total number of ways the parcel be sent by registered post is 5 raised to 4. That means 5 into 5 into 5 into 5. So I will write number of ways the parcel be sent by registered post is 5 into 5 into 5 into 5 ways. Okay, that is equal to 25 into 25, 625 ways. So there are the 625 ways we can ways parcel be sent by registered post, because there are 4 parcels and one parcel can be posted in 5 ways. Okay, therefore 5 into 5 into 5 into 5, that is 625 ways. See the next question. There are 5 books on mathematics and 6 books on physics in a bookshop. In how many ways can a student buy? First one, a mathematics book and a physics book. Second, either a mathematics book or a physics book. See, there is number of mathematics books is 5, right? And number of physics books is 6. So here, see, the number of ways to buy a mathematics books is nothing but 5C1, right? That is 5C1 combination. See, it is a problem of combination problem, right? Why? Because here order doesn't matter, right? Because why? See, let us take mathematics book. 5 books are there, right? So let us name M1, M2, M3, M4, M5, and P1, P2, P3, P4, P5, P6. Okay. See, a student can buy either M1 P1, okay, or M1 P2, or M1 P3, or M1 P4, M1 P5, or M1 P6, okay, or M2 P2, M2 P3. See here, M1 P1, okay, and P1 M1. See, what about the P1 M1? That is same, right? M1 P1, P1 M1, these are same. See, only one is enough, right? So we don't need both. So here order doesn't matter. Therefore, this problem is for combination. Okay. So here, so the number of ways to buy a mathematics books is nothing but 5C1. Okay. That is number of ways to buy a mathematics book is, there are total 5 books. Okay, so we are selecting one, that is, we select one book. So 5C1, that is equal to 5, or you can directly write 5. Okay, and next, number of ways to buy a physics book is nothing but 6C1. Okay, number of ways to buy a physics book is 6C1. C1, that is 6. Why? Because there are total 6 books are there, right? 6 physics books are there. Okay, see, now we have to find, see what is the chances or what is the total number of ways to buy a mathematics book and a physics book. Okay, so here the total number of ways to buy a mathematics book and a physics book is nothing but 5C1 into 6C1. 5C1 into 6C1, that is 5 into 6, that is equal to 30. So in 30 ways a student can buy a mathematics book and a physics book. Okay, now what about the second one? See, second one is either a mathematics book or a physics book. That means a student can buy only one book. Okay, either mathematics or physics. So there are total 11 books, right? 5 mathematics book and 6 physics book. So out of 11 books, we have to select one. A student has to select one book, right? So here total number of books are 11. So number of ways in which a student can buy either mathematics book or a physics book is nothing but 11C1, right? That is number of ways in which a student can buy either a mathematics book or a physics book is 11C1, that is equal to 11. Why? Because see, a student has to buy only one book, right? Either mathematics or physics. So there are total 11 books are there. So out of 11 books, he has to select one. So in 11 times, that is 11 ways he can select that books, right? So here he can buy, that is number of ways in which a student can buy either a mathematics or a physics book is nothing but 11C1, that is 11. So in 11 ways he can buy either mathematics or physics book.